Hi students, now problem number 3. A flywheel rotates with uniform angular acceleration. If the angular velocity increases from 20 pi radian per second to 40 pi radian per second in 10 seconds, find the number of rotations in that period. So now, what are the informations given? Angular velocity's initial value omega I is equal to 20 pi radian per second, and the final value of angular velocity omega f is equal to 40 pi radian per second. This change in the angular velocity takes place in a time equal to 10 seconds. So this is 10 seconds. Okay. Therefore, its angular acceleration. So the angular acceleration is denoted by the symbol alpha. So this is final velocity minus initial velocity by time. Okay. So this is now equal to 40 pi minus 20 pi whole divided by the time is 10 seconds. So 40 pi minus 20 pi, this is equal to 20 pi divided by 10. So this is equal to 2 pi radian per second. Therefore, alpha is found to be 2 pi radian per second square. This are you understanding first? It's a uniform angular acceleration we have found, and its value is alpha equal to 2 pi radian per second square. Okay, what next we can find out? What is its angular displacement? So, its angular displacement in the given time t is given by theta. Now, in kinematics for linear motion, we have derived the second equation s equal to ut plus half at square. Is it not? In the same lines, s is linear displacement, in place of that angular displacement. So u into t, in that initial velocity omega I into t plus half at square, in place of linear acceleration now alpha into t square. So this is the equation similar to s equal to u into t plus half a into t square. This is the kinematic equation for rotational motion, equation number 2. So what is the angular displacement is equal to, we will find out. So omega initial is 20 pi. So here this is 20 pi into time is 10 seconds. I have substituted t equal to 10 seconds. Okay, then what next? Half into. Okay, so inside this, the second term half into alpha is 2 pi. Sorry. So alpha is 2 pi. Now t is 10 means t square is how much? 100. So this is equal to 100. So 2 and 2 get cancelled. So now the first term is 20 pi into 10 is 200 pi plus 100 pi. So this is 100 pi. So this is totally 300 times pi. So what is this angular displacement? Theta. Okay. Now the angular velocity is also called as angular frequency. It is also getting another name, angular frequency. So omega is equal to 2 pi divided by period. In one full circular path, when the flywheel is completing one revolution, so all the particles in that flywheel must have made angular displacement of how much radian is 2 pi radian, and a time equal to the period of revolution. Is it not? So this can be written as what? 2 pi into 1 by t. The reciprocal of time period. The reciprocal of time period is nothing but the frequency of revolution, number of revolutions per second, RPS. So this 1 by period, okay. So this also can be written as 2 pi into n, where n is equal to the reciprocal of the time period. Understand? This n only is called the frequency of revolution, number of revolutions made in 1 second. So this only is asked. So find the number of rotations in that period. All the particles are revolving, is it not? But the wheel is rotating. So this n is also called the frequency of rotation. This only we have to find out. So omega is equal to 2 pi into n, and omega is also equal to, okay, here first of all theta is equal to how much we have got? 300 pi. Okay, now theta by t is also equal to what? Omega. So angular velocity is also equal to angular displacement by time taken. So instead of omega I can substitute now 2 pi n. So this is equal to 2 pi n. So now we are going to find out the value of n. So 2 pi n is equal to theta by t. Therefore n is equal to theta divided by 2 pi into t. So 2 pi n is equal to theta by t. I have equated. Therefore n is equal to theta divided by 2 pi into t. So what is theta? We have already calculated as 300 pi. So I am going to substitute. Therefore n is equal to, in place of theta I can substitute 300 pi divided by 2 pi into t. So this is 2 pi into t is equal to 10 second, already it is given. So this pi term get cancelled, okay, and 1 0 get cancelled. So this is equal to how much now? 30 divided by 2. So 30 divided by 2 is equal to 15. N is equal to 15. This is what actually find the number of rotations in that given period is given. Okay. So here once again for the given period, of this is per second, is it not? This is 15 per second. Therefore for the given time n is equal to 15 into 10, that is equal to 150 revolutions. Okay, 150 revolutions. So this is the answer. So this is the number of revolutions per second. But they have asked to find the number of rotations in that period of 10 seconds. So in 1 second it makes 15 rotations. Therefore in the given time it makes 15 into 10 is equal to 150 rotations or 150 revolutions. I hope you must have understood well. Fine.